Namaste everyone. Once again I come up with another question today. The question is on the board. Is the moon revolving around the earth or earth revolving around the moon? The question looks very unintuitive. The first part of the question looks very alright. What about the second part of the question? Earth revolving around the moon? Is that believable? So from our elementary education we learned that moon is revolving around the earth and it completes one revolution every 28 to 29 days. Little bit corrections are there. It's okay. In reality, maybe moon is not revolving around the earth or earth is not revolving around the moon, but both of them are revolving around something else, not sun at this moment. I keep the sun out of my discussion. Okay, so in order to understand what I'm trying to say, you need a little deeper concept of physics. But one who don't know physics, I mean one who don't have any basic foundation about the physics, but they're still curious about the physics. So for them I try to explain in a very layman version, very simplified version. So once again I quote unquote say that this is not for one who know physics, I mean one who are having a deeper understanding of physics. This is not for them because my explanation will hurt them. This explanation only for one who love the physics and the undergoing things, but they feel very hard to understand the mathematical background behind the physics. So for them only, the first concept you need to understand is the concept of center of mass. Center of mass, by the name itself, I call it as a COM. It's the center of the mass. That means where you can balance the mass. Okay, for your understanding, I'll give the idea. If we have this kind of a rod, if it is a rod, in order to balance this rod, if it is a uniform rod, in order to balance this one, so if you give a stick where you are able to balance, obviously in the middle. That means the distribution of mass this side matches with the distribution of mass this side. What I mean by distribution, I'll give the idea. If I have a mass here, this is 1 kg and this is 1 kg. Okay, actually what you call, if someone asks you what's your weight, you say 50 kg, 60 kg, but actually that is not your weight, that is your mass. Okay, weight has a different definition. So I connected a certain rod and it is 2 meter. If I say 2 meter, so 1 kg and 1 kg, where you have to balance, you can balance at the center. That means this side is 1 meter and this side is 1 meter. Okay, I see certain equation to find this balancing point. I call this one as a balancing point. How to find that one? There is a kind of an equation is there. I can see very simplified equation. Okay, so if I call this mass is m1 and this distance, okay, from the balancing point to this body is r1. Similarly, this mass is m2 and this distance from the balancing point is r2. So where you can get the balancing point? Always this product should match. This product should be equal. This is our equation. m1 r1, m2 r2. That means if m1 is greater than m2, then r1 is lesser than r2. I'll give another example for purpose of understanding. If I have a 2 kg body and I have a 4 kg body and I connected, so from this center to, always we measure the distance from the center of the body, don't worry, we'll measuring from the center, and this one is 6 meter. Okay, this rod is 6 meter. In order to balance this one, where you have to place, so I have to calculate in such a way that this mass and distance product of this side is balanced with mass and distance product of this side. This is 2 kg, so I get the balancing point here. That means I have to place a rod here so that I can balance. You usually do that one. How? This is 4 meter, this is 2 meter. You can check. m1 2 kg, r1 4 meter 8, m2 4 kg, r2 is 2 meter 8. So this product is balanced with this product. You can notice something, as this one mass is getting heavier, here this mass is getting heavier compared to this mass, then this balancing point gets shifts to heavier body. Look here, this is 2 meter, this is 4 meter. If I increase this mass, this balancing point, this point will shift to this heavier body side. I call this balancing point as center of mass. Okay, that is actually a center of mass in a very easy definition. But in physics, the definition of center of mass is actually obtained from the solving the Newton's equation of motion to a system of particle. But you don't worry about it. I'll give a simplified way. But in order to get a balancing point on the surface of the Earth, this balancing point is called center of gravity. But in our uniform gravitational region, for our moderate object, center of gravity is always coincide with the center of mass. Don't worry about it. This is center of mass for us now, so it's okay. Okay, now another thing is, you come to know that one center of mass is always lies in this line only. It is always lie in this line only. In this line means center of this one to the center of this one. If you draw a line, the center of mass is always lies in this line only. That means if I have an object here and heavier object here, if I'm not connected the rod, because why I connected the rod? To balance only. Now I don't need to balance. Okay, if it's a center is here, I draw somewhere here for purpose of understanding. It's a center is here. If I draw a line, okay, simply draw a line. It's not a rod, it's my imaginary line. Where is the center of mass? In this line only, maybe somewhere here, close to this one, because it's a heavy, right? Even though there is no rod, there is no ball, nothing is there in between, but center of mass is here. How to calculate that one? Using this equation. That's the idea. Okay, what is the use of this one? There is something called in physics, okay, when two objects are there, two or any number of objects, but for our example I'll take only two objects. If two objects are there, they're living together and no one disturb those two objects. If suppose no one disturbing means no one pushing or no one pulling. In physics terms, no one applying the external force to that object, two objects. If it is as it is, then it will move in such a way that two objects move in such a way that it always maintains the state of the center of mass. The state of the center of mass. It can move, this can move in any way. It should maintain the state of the center of mass. What do you mean by state? Center of mass, if it is initially at rest, okay, in no one disturbed, it is always at rest. A center of mass is initially moving in a one straight line. It is always moving in a given straight line with a constant velocity or constant speed in a given straight line. That is constant velocity. So I'll give a simplified idea. This is one body, this is in another body, it's here. Okay, I'll draw a simplified body, very small body. Okay, so obviously where is the center of mass? Along this line only. There is no rod, okay, there is no rod in between. Center of mass is somewhere here. Just imagine if it is at rest, for example, it is at rest, center of mass is at rest, it is not moving. Then if these two bodies are moved, they should move in such a way that it should be always at rest. That means if suppose this body moves here, okay, I say this body moves here, it is here. If this body as it is, then center of mass should come in this line, right? I already said center of mass is always in between center to center. Then if this body moves, if this does not move, center of mass will come here. But that is the violation of the rule. I already said that, right? If this body is, the system not disturbed, center of mass is always should be at rest. So in order to make that happen, center of mass should be at rest. So this body will come here, so that center of mass should be at rest. When this comes here, okay, sorry, don't measure the size, this will come here. When this comes here, this will come here. So always this point is always at rest. Okay, it can move anyway, in a such a way that center of mass maintains its state. At this moment it is at rest, it is always at rest. This is so happened in the case of Earth and Moon system. So, initially I take Earth and Moon system as just a dot, okay, just a dot. This is Moon, this is Earth, okay, just a dot, don't worry about it, I'll change that one later. Okay, so obviously I draw an imaginary line. Where is the center of mass? You know that one, it is very close to Earth, because Earth is very much heavier. how I can say I can't tell the number, it's how much of 1 after 24 0 kgs, but in comparison, if earth is 100 kg, if earth is 100 kg, then moon, we know that one, moon is moving, moon is revolving, and earth is, we believe that earth is stationary. If that is the case, this system is, this two body system, it is, we call it as a two body system, moon and earth. If it is, just imagine, it's not disturbed by anybody, that is no external pushing or pulling. You may say that when sun is there, sun is attracting us, but for the discussion, for the purpose of understanding, I'm neglecting the sun's interaction at this moment, so it will be okay. Suppose earth, moon only moves. If moon moves here, okay, I say moon moves here, if this is a stationary system, the center of mass is here, okay, this is an isolated system. If center of mass is initially at rest, as I said here, it should always be at rest. But what if a moon only moves here, earth stays at rest, then center of mass shifts here? That should not happen, as I said, right? That is a violation of the physics law. So in order to make this happen, that I should draw the line here. That means earth moves here. When moon moves here, earth moves here. Got it, right? Okay, when moon moves here, earth moves here. So like that, if I draw, this goes here. So like that. As moon revolving like this, earth is revolving like this. We come to know that one. Okay, I treated earth as earth and moon as a point. We come to know that one. Moon is not revolving around the earth. Earth is not revolving around the moon, but both of them revolving around some imaginary point. That point is center of mass. That's the idea. But fortunately or unfortunately, I already said, as mass of the one side is increases, this body shifts towards, this center of mass shifts towards the heavier body. Now what really happened in the case of earth and moon system, now you consider this is moon and this is earth. This earth is getting heavier, at the same time getting bigger also. So it is getting bigger and bigger and bigger. What really happens, this center of mass shifts in towards the heavier body, but finally it is getting heavier in size and bigger in size. The center of mass comes inside the earth. So in case of moon and earth system, that center of mass, I said, right, that balancing point, we got it from this equation, it is inside the earth. That means this point, it comes inside the earth only. It's somewhere here. Okay, I erase this line. This line, it's inside the earth only. So every time sun moves here, earth spins something like this. Sun spins something like this. Something like this. Something like this. So earth is some kind of a tilting kind of, either kind of wobbling. It's not a spinning. The spinning is a different thing. Yeah, earth rotates, you know that one. That's not a spinning, it is something different. Okay. So after this discussion, I come to, it came in my mind that if I have a two star system, two massive systems somewhere in space, somewhere, both of them are having almost the same equal in mass, understood? Almost equal in mass. If I take those two masses here, one is here and the one is here, almost equal in masses, then their center of mass somewhere exactly at the center, right? So suppose this one rotates, this one moves here, obviously this one should move here, because I already said, right, this point should be in this region only. It should always be in that position only. So in such a way that when this moves here, this one should move here in order to maintain the position of the center of mass. It's like once this one here, when this goes here, and they are taking their places each other. It's like both of them are understanding very well. It's not like in the case of earth. Earth is almost looks very stationary, moon is rotating, right? It's not so understanding situation. Here very understanding situation is there. I can connect this one somewhere in Hindu mythology or Indian astronomy. that after in a Hindu ritual, after getting married, husband shows his finger, pointing his finger and showing his wife that there is a star system, that is Varundhati and Vasishta Nakshatra. Actually, those are on the binary star system. We can see naked eye Arundhati, but we can't see Vasishta. This is too faint, not too bright. But actually these two are there so it's like not only they are exist in a story of a mythology, it exists exactly there in sky also, that is Arundhati and Vasishta. Actually they are a double star system. Double star system means they are almost having an equal masses, not exactly equal. There is a little difference in masses are there. One is 1.8 times the mass of the sun, and another one is 2.2 times the mass of the sun. Little bit errors are there, but almost having equal masses. So they are like this. They are understanding each other and revolving around a center of mass. Why particularly we are showing to pointing towards that double star system? Because husband and wife should behave like that only. Both of them are understanding each other. Unlike Earth and Moon system, they should understand each other, and so no one is stationary. So both of them are understanding and revolving around each other. So maybe that I read somewhere. So that's a good concept actually. So thank you.